Okay, so let's talk about mid conditions. A mid condition is basically the word for the predicate that lives in the middle when you want to do a sequencing rule. So this is the sequencing rule, right? Here, Q, these Q's, these are the mid conditions. And when we do the sequencing rule backwards on some statement we wish to prove, we have to find what that mid condition Q is, right? So for the rest of this video, I'm going to let the mid condition be called M, because the M mid condition starts with the letter M. So the mid condition has to satisfy two properties. It's going to be strong enough such that MSR2, this is a valid Hall triple, but not too strong, because it's also going to be weak enough such that P, S1, and M also holds, right? So let me give you an example. Suppose we were trying to prove, let me think. If x is equal to 0, and y is equal to, we assign y the value of x plus 2, and then z is assigned the value of 2 lots of y, 3 lots of y, let's make it a different number. Then afterwards, what should z be equal to? I guess z should be equal to, so you take 0, maybe I'll change this number, I'll make it something weird, make it a 7. So you take 7, you add 2 to get 9, and then 3 9s are 27. Okay, z should be equal to 27. Okay? So if I want to prove this statement, I've got to prove two things. I have to prove if x is equal to z, y is assigned to be x plus 2, then some condition m. And they're also going to prove the same condition m, z is 3 lots of y, then afterwards z equals 27. Okay? What mid condition should I choose? Well, there's basically three main strategies to guessing a mid condition, and they usually ought to work, because we have this property, can't be too strong, can't be too weak, right? So if I chose M to be as strong as could be, what's the strongest possible thing? Well, false, right? False is the strongest thing. If I put false here and here, well, false, some code, post condition, well, this would definitely be true, right? Because if the precondition is false, then the whole thing's definitely true. But if x is 7, and you add 2 to x, and store that in y, then false. Well, that's clearly not true, right? False is way too strong. Let's consider the other extreme, true. Well, definitely this is true, right? Some precondition, some code, then afterwards true. Well, yep, definitely that's going to hold. But here, true doesn't give me enough information to work out z must be 27 if z was assigned 3 lots of y, right? So true is too weak. So see how we have to satisfy both of these constraints, right? Not too strong, not too weak, it's going to be just right. So here's one strategy. We'll look at strategy 1. Make M as weak as possible, such that M, the second piece of code, and the post condition R holds. So I need M to be as weak as can be, such that if Z is assigned to be 3 lots of Y, then Z is equal to 27. So what's the weakest statement here, the least amount of information I need, such that if I run this code, then I can guarantee Z is 27 afterwards? Well, I guess the weakest possible thing could be either Z is equal to 27 or Y is equal to 9, right? Either of these would work. Right? Either one of these alone would suffice. So I guess if I write Y is equal to 9, that's a stronger property than this or this, right? So if I write both of them and connect them with an OR, I don't think I could get much weaker than that, right? No, this won't work actually, because if Z is equal to 27 and Y is not 9, I do this assignment, it won't be 27 afterwards, so that won't work. Looks like it's got to be this, right? It's got to be Y is equal to 9. Okay? I can't assume anything less, because if Y could be 9 or something else, Z might not be 27. So that's as weak as could be. And so if we insert this to the first piece of code, if x is 7, and y is assigned to be x plus 2, then y is 9. This looks strong enough to prove this, and weak enough to prove this. So this looks like a valid choice for the mid condition. Okay, what else could I choose? So let's try strategy number 2, make it as strong as can be. So we've got x is equal to 7, add 2 to x. What's true afterwards? I want to write down the maximum amount of information, but not too much, maximum amount of information such that this condition is still true. Okay? Well, I guess x is still going to be 7 afterwards. And y is going to be 9. And I guess I don't really know anything more than that, right? I could add on redundant I is equal to I and j is equal to j, but that doesn't make this strictly stronger, right? This is as strong as could be, or at least equivalent to a statement that's as strong as could be. So if I use this as a mid-condition m, let's see what the other piece of code's going to be. So x is equal to 7, and y is equal to 9. Z's assigned to be 3 y. Afterwards, z's equal to 27. This looks provable, right? The fact that x is equal to 7 doesn't help you, but it doesn't harm you, right? It's just like redundant information. So it looks like our mid-condition could be y is equal to 9, or our mid-condition could be x is equal to 7 and y is equal to 9. Let's look at the third strategy, which is just do assignment rule backwards on the second piece, the second whole triple, and hope for the best. So I've got z is equal to 27. Do the second piece of code. Z is assigned to be 3 lots of y. So what's got to be over here, such that if I replace 3y with z, I get this over here. Well, I guess 3y is equal to 27. Okay? By doing the assignment rule backwards. So that's another choice for my mid-condition. 3y is equal to 27. And you can see these things are all more or less equivalent. I mean, not the second one. The second one gives you a strictly stronger statement, but you won't need it anyway. But these are 3 different tactics to find a valid mid-condition, such that you can prove something using the sequencing rule. Usually I use tactic number 3, but sometimes it might be more appropriate to use 1 or 2. But that's just 3 different ways to find a mid-condition. You may find, depending on the proof you're doing, one might be better than the other. Certainly here in statement number 2, this is more information. Maybe that's useful. I don't know, right? That's just, 3 different ways to do it.